So now let's come to my claim that this winter is a particularly good time to be on the lookout for auroras. These coronal mass ejections are absolutely crucial if we want to see auroras down here in the central belt of Scotland. And the chance of a coronal mass ejection changes from year to year because the sun has an activity cycle. Okay? If we went back to 2007 and looked at the sun, you could go most of the year without seeing a single sunspot. Now, just having kind of reached the end of 2014 and crossed into 2015, there's sunspots, many sunspots on the disk of the sun most days. And for that same reason, well, 2014 was a great year in terms of having flares and coronal mass ejections compared to the last few years. Indeed, the auroras paid us a visit back in February. There's a very nice display here. Now, the point we're at just now, well, we're at what's called solar maximum. And that means that we're kind of at the peak of this cycle. So the perfect moment, if you will, for hoping to see an aurora. It doesn't guarantee one, I can't promise it, but we're at that right point, and the predictions are that likelihoods are going to diminish over the next couple of years again towards the next solar minimum. So if you are hoping to see an aurora, do please stay alert just now. Okay, I want to leave lots of time for discussion because we're a big group tonight, but I'll wrap up this section just now by kind of summarising what it is you might hear in the run-up to seeing an aurora. And this kind of ties in a bit with how people predict them as well. If you have a friend who's an amateur astronomer, imagine he comes in one day and tells you he's very excited because he's seen a big sunspot is on the sun, and that people are thinking that this might be the one that produces a lot of solar flares. Okay, that same event kind of happened this year and it didn't produce a lot of solar flares, but people who are kind of watching for what can happen long term can get excited at that point. Indeed, the governments and the Met Office are going to be watching it at the same time and producing probabilities. But our ability to forecast a flare, it's nowhere near the accuracy with which we predict weather at the moment. Okay, we're very much, instead of having a physical model and running it forward and seeing what is going to happen, or what is most likely to happen, we're very much kind of at the stage where people looked up at the clouds and said, well, it's got this kind of shape, I think that's going to mean thunder. There is more science that's gone into it. People very carefully categorize these things, and they have lots of data that they go back to refer to, but it's still that same kind of probabilistic approach. Bringing it into something more physics-based is one of the great goals just now that scientists all around the world are working together on. Okay, so we have the sunspot, and let's say that things go well. The sunspot produces an X-class flare. Not only that, it's a big X-class flare, let's say X5, because this is kind of my dream now. And not only did it do that, it also did it while it was in the middle of the sun. And a coronal mass ejection was later seen when they checked the space telescopes, which seems to be coming towards the Earth. Okay, events like that will probably make the news. Okay, Met Office scientists predict auroras could happen in 2 days' time. Okay. The scientists will then take that data, which is gathered remotely. So again, we don't have the same advantage of being able to measure like meteorology does for storms here. And they'll put it into a computer model. And from that, they'll try and predict when it's going to arrive at the Earth. And that gives us our information about, well, what timing should we expect the auroras to happen? Okay. Those models are pretty good in that they'll predict one arriving in about 2 days' time, and they'll get it right within a window of 6 hours either way. Okay, so that's kind of a 25% error, but this is progress on what's been done before. Now, everyone's getting very excited. It's been in the news. This has also happened before without auroras actually being viewed. And the reason for that is, remember what I said about the magnetic field direction being absolutely key. And right now, that's something we can't predict. So it's an entire gamble. The first time we get a measurement of it is when it passes a satellite which is positioned at the Earth's Sun Lagrange point, is its name. That's a place where the Earth and the Sun's gravity cancel out, and we can keep a satellite stationed there using very little fuel. The coronal mass ejection sweeps over this satellite, and then we start to get the first reliable measurements of, well, what is the magnetic field strength? If it's strong, that's good for auroras. If it's pointing south, call this BZ negative, BZ I guess because Americans coined the term. And if there's a good strong solar wind speed with that as well, then we're on. Okay. Just an aside, the Scout satellite that takes these measurements, it was designed for a mission of 5 years. It's been there for 17 years. At the moment, it's the only thing that can do this job. Fortunately, people have got a little bit nervous about this, and I was delighted to learn that a replacement is due to go at the end of January. So hopefully we won't just be relying on this one very old satellite to give us this information for much longer. Okay, now we get to the really good bit. We see that auroras are likely. We've been given 1 hour's notice that the right conditions are being produced. We run to a window, we look up at the sky, and there are no clouds, for once. At that point, please get yourself somewhere dark, somewhere away from the lights of cities if you can. Look somewhere where the sky is clear and there are not clouds. And give yourself time. Let your eyes adjust, because hopefully, when that storm arrives, it's going to create magnetic disturbances that we need. It will send the auroras our way, and I hope that you too will share firsthand in what is a fantastic, natural, planetary, spectacular experience.